Good morning, everyone. Today I'll be discussing about ellipse. As we have already discussed in identification of conics, that for an ellipse, delta would be non-zero, h square will be less than ab, or in other words, we can say eccentricity would be less than 1. First of all, we'll be proving the standard equation of an ellipse. For this, we'll be using one of its property, which states that ellipse can be defined as locus of a point moving such that the sum of its distance from two fixed points always remains constant. Ellipse can be defined as locus of a point moving such that the sum of its distance from two fixed points remains constant. As we are proving the standard equation of ellipse, so I am considering these two fixed points as S1 and S2 and their coordinates as c comma 0 and minus c comma 0. I have placed them on the x-axis, okay, in such a way that their midpoint is origin, or you can say I have placed them equidistant from the origin on the x-axis. Why I have done this? The reason simple is I'm going to prove the standard equation of ellipse. So these are my basic standard conditions for proving that is standard equation of ellipse. Okay. So let's consider that moving point as point P having coordinates h comma k. These are variable coordinates. P point is moving, so h and k are variable coordinates. Okay, whereas s1 and s2 are two fixed points, so c comma 0 minus c comma 0 are fixed points. Okay, so as per the property ps1 plus ps2 is constant, and I am considering that constant value as 2a. 2a I have considered that constant value just because in order to make my calculation easier. So using distance formula, ps1 will be equal to h minus c whole square plus k square whole under root plus whole under root h plus c whole square plus k square is equal to 2a. Now I am considering this whole under root as L and this second under root as M. That means this expression is written as L plus M is equal to 2A. If I'll be writing L square minus M square, then L square means I have to whole square this particular square root expression. And when I'll be whole squaring this expression, the under root would be removed and I'll be left with h minus c whole square plus k square. So this is my L square minus M square, as I have considered this under root as M. So on whole squaring it, I'll be getting what h plus c whole square plus k square. Finally, I can say L square minus M square will be equal to h square minus 2hc plus c square plus k square minus h square plus 2hc plus c square plus k square. I think h square c square k square h square c square k square would get cancelled out. And finally, L square minus M square will be equal to, here I'm having minus 2hc and this is also minus 2hc. So L square minus M square is equal to minus 4hc. And I'm making this as equation 2. If I divide equation 2 by equation 1, that is I'm dividing L square minus M square with L plus M. So on RHS, I'm having minus 4hc upon 2a. Finally, I can say that L minus M will be equal to what? Minus 2hc upon a. Considering this as equation 3. Now I'm adding equation 1 and equation 3. Equation 1 is L plus M is equal to 2A, and equation 3 is L minus M is equal to minus 2HC by A. So when I'll be adding these two, I'll be left with what? 2L, because M and minus M would get cancelled out. So finally it is 2A minus 2HC by A. 2 would get cancelled out. L square will be equal to A minus HC upon A whole square. L square will be equal to whole square of this under root expression. That means this would be what? H minus C whole square plus K square, which would be equal to what? A minus HC upon A whole square. This implies H square minus 2HC plus C square plus K square is equal to A square minus 2HC plus H square C square upon A square. I think minus 2HC and minus 2HC gets cancelled out. Finally, H square, I'm bringing this expression H square C square upon A square on the left hand side, that is minus H square C square upon A square here. K square remains on the left hand side, A square remains on the right hand side, and I'm moving this C square on the right hand side. This becomes minus C square. Finally, I'm taking H square common in these two expressions. So I'm left with 1 minus C square by A square plus K square is equal to A square minus C square. Finally, this becomes H square into A square minus C square upon A square plus K square is equal to A square minus C square. Finally, I'm dividing this complete expression with A square minus C square. Then I'm left with H square upon A square plus K square upon A square minus C square is equal to 1. Finally, I am replacing H and K with X and Y respectively. So this becomes X square by A square plus Y square. And one more thing I'm doing here is I'm replacing this A square minus C square with an expression B square. Here I'm mentioning this, that in place of A square minus C square I have written what? B square. So this gives me my standard equation of ellipse. By writing A square minus C square is equal to B square, I have considered as of now A is greater than B. So now using this standard equation of ellipse, I need to draw this particular graph of ellipse. Okay. So for drawing graph of ellipse, let's consider few more things. As equation is x square by a square plus y square by b square is equal to 1. I think at x-axis y would be 0. This means x square by a square would be equal to 1. This means x square would be equal to a square. This means x would be equal to a or minus a. That means my ellipse would be intersecting x-axis at a comma 0 and minus a comma 0. These 2 points. At y-axis, x would be 0. This makes y square by b square is equal to 1. Because now this expression, in this expression, x square by a square, this terms becomes 0 as x is 0. So I'm left with y square by b square is equal to 1, or you can say what? Y square is equal to what? B square. This implies y is equal to b or minus b. This means my ellipse is going to intersect y-axis at 0 comma b or 0 comma minus b. So finally, if I try to draw the graph of my ellipse, previously I had drawn only two fixed points S1, S2 with coordinates c comma 0 and minus c comma 0. Now I have four additional points from where my ellipse is passing. These points are, first of all, this is A1, A comma 0. This is A2, minus A comma 0. This is B1, 0 comma B. And this is B2, 0 comma minus B. So my ellipse would look something like this, passing through these points. In this conic, as we are having two fixed points, that means we are having two focuses. So corresponding to these two focuses, we'll be having two directrix. One corresponding to the S1 would be this, and corresponding to the S2, this would be its directrix. Okay, so these would be the two directrices. These would be the two directrices. This one would be for focus S1, and this one would be for focus S2. Now, where I need to place this directrix after A1 or between S1 and A1 or before S1, this needs to be clarified first of all. So for that, let's consider this point B only. So with respect to point B1, if I see B1 S1 would be the distance of point B1 from focus S1, and B1 M1 would be the perpendicular distance of point B1 from directrix corresponding to focus S1. Okay, and we already know as per the definition of conic, distance uh, of any point on the conic, distance of any point on the conic from the fixed point, that is the focus, that is B1 S1, with respect is to the distance from the fixed line always remains constant, which is equal to what? Eccentricity, which is equal to what? Eccentricity. Okay, which is equal to what? Eccentricity. This would be what? E. So if I see B1 S1 would be what? C square plus B square upon B1 M1. As we already know that B square was written in place of A square minus C square. E is cross multiplied here and B1 M1 here. So C square gets cancelled out, and under root of A square becomes A upon E is the value of B1 M1. That means the perpendicular distance of this directrix corresponding to focus S1 from y-axis is nothing but A by E. This perpendicular distance actually gives me the equation of directrix. Now the equation can be clearly stated as x is equal to A by E, as it is a vertical line. X is equal to A by E. And I can clearly say that this directrix would be placed right side of the vertex A comma 0. Reason is very much clear, because I think this x is equal to A by E clearly shows that A is getting divided by E. And when I'll be dividing a value with a value less than 1, because eccentricity is less than 1, On dividing a with a value less than 1, this complete expression a by e would obviously be greater than 1. Because when we multiply something with a value less than 1, the value decreases. When we divide something with a value less than 1, the value increases. So the value of a would, so this value a by e would be greater than a. Okay. So I can clearly say that this particular directrix would be on the right side of the vertex A1. Clear? So this equation of directrix would be x is equal to a by e, and this equation of directrix would be x is equal to minus a by e, as it is on the left side. Okay. So now with respect to point A1, with respect to point A1, that is vertex A1, I'm going to do the similar thing. A1 S1 would be the distance of A1 from focus S1, and A1 N1 would be the distance of vertex A1 from directrix corresponding to focus S1, and their ratio A1 S1 upon A1 N1 would also be equal to what? E. Yes, eccentricity. Clear? What would be A1 S1? I think the distance of A1 from origin is A. The distance of S1 from origin is C. So I think A1 S1 is nothing but A minus C. So A1 S1 is A minus C upon A1 N1. If I can say that the distance of point N1 from origin, this would be A by E. Similarly, distance of A1 from origin is A. So A1 N1 would be what? A by E minus A. So this would be A1 N1 would be A by E minus A is equal to E. So finally, A minus C is nothing but E into A by E minus A. Finally, I can say A minus C is equal to A minus AE. A gets cancelled out. C is equal to AE. So finally, I am having the coordinates of my focuses as AE comma 0 and the other focus minus AE comma 0. So that's all for today's session. Thank you very much.